So,
I'm just clicking start recording this session.
okay, it's good, sir. If you
For,
if you have to review, you can review.
yeah, folder structure, and after the folder structure, Android itself has its own architecture. Android SDK has its architecture, and then the actual coding things that comes into the matter, those are components of the Android, and the components regarding life cycles of components, and then we step into the initial program or the first program of our Android. First programs, then the part is UI. UI has around 30 examples, 30 to 35 examples we need to see, takes more than a week. After UI, it could be something like media. It is how the media, audio and video, and those playing and playbacks and all. And the database, then it is SQLite database, around 5 to 6 examples we see there. It takes 2 to 3 days. Once the database is done, then the HTTP connection making and getting data from the servers and all. After that, parsing techniques. The parsing have different things, SAX, DOM, and within that again XML and JSON parsings are existed. All these things, some seven, oh no, 6 examples or 7 examples on that. And after this, that's related to networking, HTTP and parsing are. And after this, a bit of the hardware, Wi-Fi using permissions and all those things, hardwares, and then the third-party integrations. It could be Facebook, could be Google, or any payment gateway or something else. And then this is the core part, the all the part that involved in something like that goes on depending on the requirement, something like that goes on. So it's basically all comes around 70 examples nearly. Those are, it could be greater than 70 as well. So 70 examples I am going to type over here, and those you are going to see and understand what each method and everything is going to be and how it works and all. Bit prior to all those things, the first a week classes could be theoretical things. So now I'm taking the first part of our course, that is the Android application conversion. What this is, application file conversion. The concept is, say, suppose when you're trying to install any application in your mobile, then within that mobile, application is being installed from the Play Store. But what exactly, which formatted file that installs into your device from the Play Store is .apk file. It is the final executable file of an Android, final bundle, final thing that what developers keeps into the Play Store and end users downloads that and installs it into their devices. So ultimately, once we develop a complete application and build that and generate something, that build has to be given to the Play Store, means making that available to developer, available to end users in the format of a .apk file. .apk doesn't mean that Android package. It doesn't have any special meaning. It's very simple, Android package. So this .apk file generation, how it happens when we are developing any application. If you develop a very small application with 1 or 2 lines of the code or 100 .java files and 100 XML files and all, at the end it could be a .apk file. It should be a .apk file. So what this .apk file or how it will be generated. So before going to that part, I would like to compare this, how the file conversions are going to happen in 3 different stages. Let us say, let us take C programming language or C application, a Java application and an Android application. How the things could happen, let us see. Suppose say, I am developing one application and the programming language I am choosing is C. Guys, if you are not comfortable at any point of the time, just remind me. I
Okay,
think
sir.
these are the very small things. Once we come into
Yeah, sir.
Android, then the discussion may come in. The next 5-10 minutes are your known things only. Just for comparison, we
Yes.
are discussing those. Say, I'm writing my application in C now, and I'm able to manage all my code within one single file, and the file name is say 1.c. The file name is 1.c. So what could it consist of? Guys, let me know what this 1.c will consist of. We need to save the file with the .c extension. If it is a C programming code and all existed in that, 1.c is the file. Huh?
Okay.
Yeah.
So what it consists of is, say, let us say I am writing something like this, C equal to A plus B something. So it could be something, a valid instruction in C.
Mm.
C programming language has given some syntax. It has some rules and regulations. Keywords should be like this only. It shouldn't start like this. Variable should be something like this, something like this. Some instructions and rules and regulations were given by C. So by following those rules and regulations of the C programming, my requirement is being kept there in 1.c as a code. Say this is one of the line within the 1.c.
Okay.
Now, what we call it is as source code.
Source code.
Source code. But source code wouldn't be given to any client at any point of the time for execution. For execution, source code is not a thing. It has to be compiled and generated as a build. That build has to be given to end user client, that is in the format which is executable. That executable
Executable code.
file has to be generated from this source code. So generally in our academics, what we do, once we write a C program, we go for a compilation and then running. Alt F9 or something we use to compile
Control
that
F9.
code. Yeah, Alt F9 is to compile and Control F9 is to run the code.
Run.
So once we press Alt F9, what could happen? What is happening in the background?
Source code is converted to the compiled code.
Source code is being converted into some other format. 1.c is
Some other
going to be
format.
converted into some other format. Can anyone
Machine understandable.
remember what that format is?
Machine understandable language. Native language.
It could be .exe file it is. Yeah,
Yes.
it's a machine understandable
Executable
language. It is not byte code, byte instructions, 0 1s, those are not the thing. It's not zeros and ones. It is machine understandable format. Let us say it could be something like embedded kind of the coding, middleware level of the
Okay.
coding, which is generally used in driver programmings and all directly.
Okay.
Let us say the machine understandable code for that above line C equal to A plus B, for that line, how it could be converted, say C add A comma B. It could be something, it's not the exact syntax, I'm just giving for your reference.
Okay.
It could be something like this. When I compile my code in Microsoft Windows operating system. Remember that here I am doing Alt F9 means compilation of my code in Windows operating system.
Okay.
So it generated 1.exe and generated C add A comma B. If I compile the same code in Linux operating system, it could be something different. C space A comma add and then B. It could be something like this in case of Linux. Why? Because C is platform dependent language. We all know that C is platform dependent language. What that platform dependency is here. Once you compile your source code, even though the source code is same, the generated executable code could be different on different platforms. So that could be according to the architecture of the Windows operating system and according to the architecture of Linux operating system.
Yeah.
So the compiled code could be different. So what happens here is I have 1.c and compile that to 1.exe on Windows. If I give this .exe file to an end user, mean my client, and the client is trying to run the same in Linux, I compiled on Windows and client is going to run the same .exe file in Linux, but Linux is expecting C space A space add space B, but existed is C add A comma B. That's the problem, right?
Platform dependent.
That's what we call here as platform dependency.
Dependent. Okay.
Anyway, as we are going through, that point will be linked in the next two conversions. That's why we are discussing about platform dependency and all.
Okay.
We need to understand what the final executable file of the Android consists of. For that, we are discussing all this. So platform dependency it is. Something existed. So at the end, it is 1.exe. And what 1.exe consists of is some kind of the middleware programming. And that kind of middleware programming existed within is platform dependent. Fine? Now come to the part of Java. Oh, Control Z doesn't come. Oh, space gone. Okay, let's come to Java here. Suppose the same application, if we need to prepare in Java, then there it is 1.c. The corresponding file, what could be here? Say the file name is one only, and I am able to manage all the code in a single file. It is 1.java. We know once we install Java SDK, we get Java C, Java compiler.
So you can use the arrow buttons or the top left corner, so that you can get back the here, or you can.
I pressed Control Z, but it didn't came.
Yeah.
I pressed Control Z for the shortcut. Control Z only, na?
Press multiple times.
It's going to initial case. That what happened is
I got it.
No. That what happened?
Now I tried in my laptop.
No. What happens is, suppose say I am typing text. Here it is, and I am typing something. If I come out and then do something, then it comes in. If I say escape, I have given escape. It doesn't come in now.
Okay.
So, or else if I do something like this, preparing one and this box, I'm coming out of the box, then it comes. So the state is not yet committed within. Got it. Now Control Z and Control Y, now it comes. That state is not yet existed. That's lost. Okay. So 1.java is our file which has all our source code. Suppose say what it has is according to similar to C, Java also has given some syntax rules, regulations and all the stuff. Obeying all those rules, we have written our code. We have learnt all those instructions, rules, regulations, and implemented some code according to our requirement. So now we need to compile this. Again, it's a source code which couldn't be given to the end user. It has to be converted into executable format. What that executable format and how we convert is Java C. Once we install JDK, then we get this Java C. Java C is the one which converts your .java files into which format? It converts into .class files. Now can you say what the .class file name is? One.class or anything else?
One dot. Yes, sir.
Correct only?
Yes, sir.
Say I'm writing a piece of code C like this. My file class name is this. Add some code.
Sorry.
Class 2 is there. Class 3 is there. Remember that all these were saved within the same file as 1.java. Is it possible or not first?
Possible if we have the main class in class 1.
No, I don't have any public static void main. Let us say I don't have. Possible. Then if I compile here Java C space 1.java, my file name is one only. I don't have 2.java file. Within 1.java file only I have class 1, class 2, class 3. What happens now?
If there is any code in the class 2, class 3, just empty.
Existed, let us say. Is available.
Only class 1 also. Only class1.java will be executed.
No, I am saying about compilation, not execution.
Oh, compilation.
Once after compilation,
Only one dot class file will be generated.
No, it generates one dot class, two dot class, three dot class. How many classes are there within the file? Those many dot class files will be generated. And before that, one more question is,
will be different. Okay.
one more question before that is this one dot Java, whether it is possible or means, yes, it is possible unless and until you have public for all the classes. If you have public for one, or else say if you have public for two, then it has to be generated with public class name. It has to be saved with 2.java only. You cannot have multiple.
Yeah.
So until and unless you don't have any public class, you can save it with any name, xyz.java, pqr.java, anything.
Yeah.
Once we compile javac pqr.java, then it generates one dot class, not pqr.class. One dot class, two dot class, three dot class. So the file name could be something like this, pqr.java. It doesn't mean that you will get pqr.class. Pqr.class wouldn't be generated at any point if you don't have the class. You never exist class with that name. Yeah. So with what names classes existed, all those classes will be converted into these dot classes. Now the question is, what these dot class files consists of? Previously we were discussing here about the C. 1.c and 1.exe existed. 1.c is the source code one, 1.exe is the executable code, and 1.exe consists of the middleware kind of the programming, something like that, which is platform dependent. And now we came to the same point here in the case of a Java application. What these dot class files will consist of?
Bytecode.
What bytecode is?
Zeros and ones.
Expected. Expected, guys. Your answer is correct, but what this bytecode, that is not correct. Is called bytecode.
Bytecode,
which is a combination of byte instructions. I know many people don't know this, but what it is we see now. Let us see. Concentrate for 2 minutes. It can be understandable in a better way.
Okay.
Forget about all this. Come to the language English. Now a language is English. What English has? It has A to Z. I don't spend much time on this. It's not related to us, just for understanding. Which has 26. Can I say these as instructions for this language? Instead of alphabet, some instructions. By using these 26 instructions only, I can write a word, I can write a line, I can write a page, I can prepare a book, anything. So whatever existed is a combination of all these 26. Na? If I need to write my name, Kiran I want to write, then I'm able to write. Why? Because I know the instructions of the English and how to use them. I'm able to write. But all it is within the 26 instructions only. Getting my voice?
Yes, sir.
Yeah. Suppose if you say another language, Oriya or something else, French or Oriya something, I don't know what alphabets existed in this, how many are and how to use them. If I need to write my name in that, may not be possible for me. It's not possible for me. Similarly, here the person who come to the same case of Sun Microsystems. Sun Microsystems, these guys are the inventors of Java, na?
Yes.
These Sun Microsystem people had understand the problem that existed with C and CPP, which is platform dependency. Why? Because once the code is compiled on one thing, that is unable to run on some other kind of the architecture or some other kind of the operating system. Why? Because the executable file consists of platform dependent code. So I need to generate, Sun Microsystem believed that I need to generate an executable code which should be independent of platform, which can run anywhere. So this Sun Microsystem has given initially 208 instructions. For the language English, we have given 26 instructions initially. After those 26 instructions were born, anything was given. Anything is born. Similarly, Sun Microsystem has given 208 byte instructions which were called as byte. They have given some instructions and named them as byte instructions. Those are not zeros and ones. Those are not understandable to us. Who can, like Varia to me? I can't understand Varia. Like that, these 208 instructions I can't understand. Who can understand is Java runtime environment can understand those. Java runtime environment, Java virtual machine can understand those. I cannot understand. So, if you are writing a line or a name or anything in English, you are getting some instructions according to your requirement and arranging them, right? Similarly, what JavaC does is, according to the source code existed, it picks some of the byte instructions from those 280 existed and arranges them as per the source code. Got it? So this is the byte code what we call. So this byte code existed in .class files. Remember that Java is platform dependent. It is not platform independent. If you want to install Java in Linux, you need to download the Linux related Java and has to be installed. If you want to install the same Java in Windows, then Windows supporting Java has to be downloaded and has to be installed. Java is platform dependent, not independent. What is independent is, once you compile the code, what it is generating, executable code, that is platform independent. These 208 are by platform independent, not Java. So the ultimate requirement is that only. I need to execute this code anywhere. So what is being executed is those 208 byte instructions arranged in some all permutations and combinations. So the 208 instructions were prepared in such a way that those are platform independent. So your your executable format of Java, that is .exe, .class, is platform independent. Got it? Huh? So ultimately, the file conversions in C and the file conversions in Java we have seen. Now our actual thing we are going to step in. The file conversions in Android. Yesterday when we were discussing, I have started this session actually, and we went into some other discussion. So what a Android file exists of is, it has some business logic, and at the same time it has some UI and also has some resources. We were discussing this point yesterday. If you want to write any logic, business related logic, then that we are writing in Java. So some n number of the .java files will exist in our code. Some number of .java files will exist in our code, and UI will be prepared in XML files. So n number of .xml files will exist, and some resources. They could be images or the static strings prepared in an XML file, or some other styles related XML files. Something like that. These are the supporting things. Some static images and all. So these are all the things that existed in my Android application. These all has to be converted into an executable format. These are the source or the base. Those has to be converted, right? Now, in the initial phase, for Android application execution or development, we need Java. So Java has to be installed in our machine. JavaC, Java compiler comes into the picture and converts all .java files into .class files. Guys, am I going fast?
No, sir. No.
Perfect. So all .java files are converted initially into .class files in the first phase. Let us say the remaining all existed as it is. Remaining all existed as it is. Fine. One format is converted. Now, what these .class files consist of? Our previous discussion. That is required here. That's why we discussed that. What .class files consist of is byte instructions. Byte instructions. These byte instructions are understandable to JVM. Java Virtual Machine, which executes your Java application at the end. But in case of Android, an Android application will be executed by DVM is called as Dalvik Virtual Machine. This Dalvik Virtual Machine cannot understand dot class files. Dot class files has byte code, which is byte instructions given by Sun Microsystems. Those can be understandable to JVM only, but not to DVM. And the remaining things, the XML files and images are not at all converted into. Now all these has to be further converted, that should be understandable to DVM. A further level of the conversion is required, which should be understandable to DVM. So now who comes into picture is what it is called, DX machine will exist in Android. The DX will convert all, like Java C. DX converter will exist in Android that converts all these formats, any formats, into DEX files. So the next stage of the conversion is .dex files. So all will be converted, XML files and dot class files all will be converted further into DEX files, .dex files. So DEX compiler, DX compiler, let us say we can call that as DX compiler. DX compiler compiles all the things into n number of the DEX files. Now similarly, previously we were discussing about what dot class file consists of. Now what this .dex file consists of? It also consists of byte code only and is byte instructions. It means the combination of byte instructions is byte code. But these byte instructions were not given by Sun Microsystem. These byte instructions were different to the previous byte instructions. These were given by Google. So previous byte code is Sun Microsystem given byte instructions. These byte which are understandable to JVM, and these byte code consists of Google given byte instructions which are understandable to DVM. Now DVM can understand these byte instructions, not the previous byte instructions. Those byte instructions, these byte instructions are different. Both can be called as alphabets, let us say. English has alphabets, Oriya has alphabets. Similarly, Java has byte instructions, Google has byte instructions. But English alphabets and Oriya alphabets both. Anything?
Yeah, I got small doubts, sir.
Come on.
I can able to understand. I understand all this stuff. We have the two types of byte codes, one from the JVM, one from the DVM. Yeah, one from the Google, one from the Sun Microsystem. But what is the relation between them? How they are related?
It's very simple. Both are not related. Initially, Java has to be directly converted into some format which is understandable by DVM. These guys felt that the DVM is the executing one. Correct. Anything? You're asking anything in the meanwhile?
Actually, yeah. When Java is compiled, dot class file will be generated. The dot class file will be understandable by only JVM, right?
Java compiler, true.
Yeah. When you come into the Android, you are talking about DVM. When the DVM is useful in our compilation process, I didn't understand where it will comes in the right picture. What is the stage?
Can you ask it again? Can you come again?
Yeah, when we compile a Java program, the dot class file will be generated. The dot class file will be understandable only by the JVM. Virtual machine.
So they are again being converted into some other format. Yeah.
Okay. When we use in the Android, the dot class file will be again converted. Again, it will be converted, or it will be same?
No, it doesn't exist. That also will be converted into .dex files. I don't know whether these guys felt difficulty in converting dot class directly into .dex. Okay. They could face some. Why? Because .java files may be platform dependent or something else. So these files converting the executable format of Java into executable format of Android. They are not directly converting .java to .dex. Initially, let the Java C compile .java to .class. Again, Android people are converting those .class into .dex.
Okay. By the help of DVM.
There could be one more reason for this. Why? Because let us say if you are using any third-party library, so you have a .jar file. It consists of .class only. It doesn't consist of
Yeah.
.java. So the third-party library is part of your application. Then .java files wouldn't exist. .class files will exist. They has to be converted into Android understandable format .dex, right?
Okay. Yeah.
Could be that is also one of the reason I'm just thinking about as per my knowledge. I haven't read that anywhere.
Okay.
Fine. So now what we have at the end is n number of .dex files we have, right? These n number of .dex files should be published to market, Play Store. But let us say if I have 1,000 files, 1,000 couldn't be placed. All has to be
So
packed together and has to be bundled or has to be packed as a one.
so one more small note, sir. We can consider this .dx files as same as .class files in Java.
As similar as how .class to JVM, .dx to DVM.
Yeah, got it, huh. Okay. This is a small note I had in my mind. Okay.
.dvm is the one which executes Android application. How JVM to Java, DVM to Android.
Okay.
.class to JVM, .dex to DVM.
Okay.
Now we have n number of .dex files. All these .dex files has to be packaged together or has to be bundled or packed together as a single file. So here Android has one tool, AAPT, built-in tool, which is called as Android Asset, anything. Asset package tool, Android asset package tool, which existed within the Android environment, and that does this work. It packages, it builds, it generates the build. It packs all these .dex files and converts as a single file. And your application name, whatever it is, if one is your application name, then one dot something. If hello is your application name, then hello dot apk. That application name dot apk will be generated by AAPT, Android Asset Package Tool. Remember that all this goes in the background. You are not going to give any instructions to do all these things. Once we say run, it compiles and generates the .class, .dex and all, and does that packaging and all, generates a .apk. All this build process will be generated by your integrated development environment. IDE is what you use. It could be either Eclipse or recently Android Studio. Those will do all this work. Those will give all these instructions to generate. So if you click run button on the Android Studio or Eclipse, at the background all this thing goes on. Your IDE gives the corresponding instructions to Android SDK and Android Asset Packaging Tool and all. There the .apk file will be generated automatically. But we are learning what's going on and how it existed.
Okay.
You guys got it? Huh?
Yes, sir.
So this is the first part of Android. What Android exists of and how the file conversion is going to be and what we are going to put into the Play Store. It's all about the file conversion.
So .apk file is going to be put in a Play Store, right, sir?
.apk file has to be directly placed into Play Store, but there are two processes existed here. If we dig more deep, the .apk file has two conversions, two versions. One could be signed, one could be unsigned. Unsigned.apk and signed.apk file. The process of signing the .apk file will be existed. You're supposed to publish a signed.apk file into the Play Store. It generates these IDEs, Eclipse or Android Studio, those generates unsigned.apk. That file can be kept in device and click on, you can install. That goes on good. But when you're keeping it into the Play Store, that has to be gone through a process called signing up the application. What it means is you do generate some unique identification or something like that, which is called as key store here in Android.
Okay.
With that has a process, we discussed that also. So the application will be signed, that will be kept with some information, let us say at this point of the time, and with that
Referring to
information,
authentication.
it's not authentication, it's for remembrance. For what purpose means, say now you install the application, tomorrow if you go Talking Tom, you say application is Talking Tom is available, and the next time you are going to the Play Store and again searching for the Talking Tom, a new version is available. Then what those guys do is, with some version name change, they will upload the same .apk file. By the time the application shouldn't be installed secondly in your device. Already existed has to be updated. To identify the existed and the new one, both are the same, the signing process helps us. If you sign both the .apk files with same key store, then it treats as it's an extension to the existed one in the device. So that is one of the advantage of signing the application. So that has to be done before putting it into the Play Store. Got it?
Yes, sir.
That is perfect. So next is the folder structure of Android application. If you guys feel convenient, I can go ahead. If something,
Yes, sir. Go
Yes,
ahead.
sir.
okay, na?
Yes, sir.
If you feel something is overflowing or something like that, we can push it aside and can continue on the next class.
No problem, sir. Continue.
Okay. I am removing it. Anyway, session is being recorded. You can see all these there. Huh?
Okay.
Secondly, it takes a long time. We cover half of the file structure, folder structure, and the remaining half we cover again tomorrow. That could help us in the format of revision as well. Now, suppose say I am creating an application with name Hello World and sorry. Hello World is the base name of my application. So this Hello World application, once you prepare an application, the folder structure will be prepared by the corresponding IDE what you are using. We use two IDEs, Eclipse and Android Studio. So a folder structure will be prepared. What are the folders that will existed in that prepared folder structure, and what kind of files has to be stored where? That we need to understand. You got my point? What we are going to discuss? If it is a Java application, HTML files all will be saved at one place in one folder. All .java files will be saved at one place, something like that. Similarly,
Second, sir.
yeah, please.
Yeah, so I just lost his internet connection. Just reconnecting it.
I didn't get here. Can you come again?
I mean,
Yeah, Sai Kumar just lost his internet connection.
Oh, acha, acha.
Trying to reconnect.
Well, let's wait.
yeah.
Are you in, Sai?
Also, he just come.
Yeah. He's showing here. Sai, able to hear us? Seems no.
Sai.
Let me know once he is in. Huh? Hmm. Yeah, so are you able to hear us now?
Very sir.
Right?
Yeah.
Yeah, going further. We are discussing about the folder structure of an Android application. If I start developing an Android application, say just now I created a new Android application which has to be stepped in and some other more files has to be added. Some n number of .java files and n number of .xml files has to be added in. So what it all will consist of is what all the different kinds of the folders available within that main folder, what kind of files has to be stored where, that we need to know before, right? So the main folder will exist with the name, the application name what you have given, that is hello world say, which internally has, I am touching the main important folders, not all the supporting folders we can just ignore. SRC is one of the folder, SRC, and one more is resource, and one more is Android space Android SDK space some x.x something, and then one more is asset, and then resource is one more folder, and at the end Android manifest.xml is the file. These are the main files what we will be having. This is not resource here. Resource came twice. SRC gen, GEN. So these are the folders, internal. This is the main folder name. Within this folder, we will be having all these remaining folders. These are some of the folders. Let us touch the main things which can be completed faster. SRC, what it will have is all .java files it will have. If I am going to add some more number of .java files, they has to be added into this SRC.
Those files. SRC.
You know, every .java file will be existed within some package. So it could be something like com.abc. Under this com.abc folder, some .java files. .java files. That is the package name, and we package folder, within the package folder .java. SRC, under that com.abc, under that all your .java files. So source code. This gen we touch at the end. What it will have is, it will have a auto generated file which is also a Java file which cannot be edited, which should not be edited. We should not touch it. An auto generated file it will have r.java, the file name is. The file name will be r.java. We will have a session on this. One complete session is required for that. Once we start writing the code, then we discuss about this r.java. It's not possible to understand clearly if we discuss now. Why? Because it has some hexadecimal IDs generated for something and all. So once we have we are into the first application, then we discuss about r.java. And then next, this Android SDK, which is the Android SDK support required at the time of developing all our code. All that support will be given here, and this Android SDK wouldn't be added to our .apk file. It will be giving its support at the time of developing, compiling, and build generation only. But it wouldn't be added to our .apk. If it adds to .apk, our .apk file size will be very large, right? So the same Android SDK will be available in the corresponding devices where we run our code. It uses the support again there, but it wouldn't be added to our .apk file. So it is for our development, compilation, and build generation support it is. If I have some assets to related to my application which are not coding parts, They could be some supporting font family or country images or something else, some terms and conditions, static documents, something existed like that, then those has to be saved here in assets. Remember that those are non-executable code generally stored in assets. You can also store executable code, but the purpose of giving that extra folder in the folder structure is to store non-executable files, to keep all non-executable files at one place. If you have something, some extra assets related to your application rather than executing, then they can be saved here in asset folder. Initially it is empty. Until and unless you specifically externally keep something, it is empty. And then come over here. A resource consists of drawable folder. One is resource consists of drawable folders, also consists of layout folder, and also consists of values folder. Drawable means the name drawable represents images. So if you have any static images, search icon or menu icon or options icon, those all icons, static icons, if you have anything, they're supposed to be stored into this drawable folder. Static icons, if I use anywhere in my application, they has to be stored into drawable. What this layout consists of is all your XML files. The UI related, for one UI, if I prepare one XML file, 1.xml, again 2.xml, 3.xml, something like that, all those XML files has to be stored here into layout folder, right?
Okay.
And values consists of strings.xml. Similarly, dimensions.xml. You can have something color.xml, some extra files like this, values. What the purpose of these things will explain you. Suppose say in strings.xml, a starting tag and ending tag. Tag will have some name and value. That value can be accessed with the key. So now my key is bank name and the value is UTI bank. In string.xml, one of the tag existed with the name called bank underscore name and the value provided for this is UTI bank. So my application is UTI bank application. This bank name could be utilized in each and every screen or in the as part of the each and every screen. It could be title, it could be part of somewhere at n number of the say 1000 times this bank name is being utilized. If I statically write it as UTI bank, UTI bank, UTI bank at all those 1000 places, say now it is 1998 and we reach it 2008. In 2008 UTI bank is renamed as Axis Bank. Axis Bank was previously called as UTI. IFSC codes will exist with UTIB something. So now it has to be changed. A developer, if he is releasing the next version of the mobile application for that bank, then they're supposed to change this UTI bank to Axis Bank at all the places. Instead of changing that at all those places at 1000 places, 1000 areas, he can just simply change here at a string.xml. This UTI bank has to be replaced with Axis Bank and bank name has to be used as a variable at all those 1000 places. So any higher level strings key value pairs are being used in your application, those can be stored at one place and they can be utilized throughout the application wherever they want. Got it?
Yes.
Similarly, dimensions.xml. In dimensions.xml also, say an example, now I'm giving right margin and what else called one more padding. Right padding, left padding, top padding, bottom padding. So right padding 10, left padding 10, top padding 10, bottom padding 10. So whenever I prepare a new screen, that the initial space I give some padding. Means for the mobile device, on all the sides leaving 10 pixels of the space, within the remaining space I am preparing my UI just for beautifulness. For second screen, third screen, fourth screen also I can provide those 10 dp, 10 pixels, 10 pixels, 10 pixels like that. Say for one of the screen, if I provide, I am a developer doing, one more developer is doing and he is doing and giving it as 20 dp, it could be a problem. Instead of going like that, I can provide that 10 dp dimensions at one place and that name can be utilized wherever I want to provide the 10 pixels. Tomorrow, if some decision is being taken, the top and bottom has to be changed to 20 dp, then I can change that at one place. I need not to change. So the dimensions.xml is specifically given for same as strings.xml, purpose is same, but a kind of the data, some other kind of the data. Similarly colors, some other kind. Similarly you also will have styles.xml there. Styles.xml. You can prepare one style by using XML Android tags. That style can be applied to a view, that style can be applied to a screen, something that can be happened. So these are some of the files that will exist in values. Generally we use these four: dimensions, strings, colors, styles. The purpose is maintaining the same value uniquely wherever you use for our convenience as a key value pairs. So we covered source src where we keep all our .java files, and XML files where we keep is layout is the folder, and if you have some static images where we keep is drawable. If we have some key value pairs, they could be related to names, could be related to dimensions, related to styles, or related to colors. They will be kept in values. So those are the values will be utilized as a key with the help of key. So, and assets, if you have any non-executable codes, those can be kept within assets. And Android SDK, which gives a support for writing the code, compiling and build generation. So what the parts that are missing in all this folder structure is, one is gen.r.java that we see when we go for coding, and what else is manifest file. Now we discuss the manifest file and we conclude this session, and we discuss r.java in whenever we require, whenever we step into, so that it comes to a conclusion. What manifest file consists of? Say you have a Java application. If JVM need to run your Java application, from where it executes your Java code? It has some static syntax, right? Public static void main. So within the public static void main, step by step, line by line as an interpreter, the code will be executed. Similarly, Android application also should have a starting point. Where it will have is that will be available in manifest file that we provide in manifest file. Remember that one of the property, what that property we see later, that's the version again, launcher, we need to specify. One of the property, one of the action we call it as, one of the action has to be specified as launcher. This will be specified where means it will be specified outside of all your code that is in manifest file. Remember this point. So the starting point of your application, yeah please.
Starting manifest, sir.
Not
In manifest file.
In manifest file?
Starting manifest file. I mean,
yes. Yes, whenever your application is being executed, the Dalvik virtual machine first looks into manifest file and understands all the manifest. What the meaning of manifest here? Let us say one political party is going for elections, means first they give a manifest. Means once they come into power, what they will do, all that will be briefly provided over there. If you are submitting a project in your academic, means prior to submitting a project, you submit a manifest. It means that what kind of the project you are doing, what your project consists of, that is briefly explained there. Similarly, for your application, it is a manifest. What all kinds of the
code or what? That includes the source code or what? Manifest file.
Kaushik, missing your voice, not clear.
Yeah, I mean that includes the source code or what, sir?
Some noise here, some noise. Give me a second. I mute the remaining all.
Yeah, I mean what actually manifest .xml file includes?
.xml file, it is not Java code, it is XML code only. Remember that wherever you find .xml, it is start tag, end tag, meanwhile some properties and values. Getting it? Audio connection lost again. ల్యాప్టాప్ ప్రాబ్లమా లేకపోతే మరి ఇంకో ల్యాప్టాప్ ఏదైనా పెట్టాల్సిందే. కనెక్ట్ అవుతుందా లేదా? Connected network connection has been restored. Yeah. Guys, you are able to hear now?
Yes, sir.
Yeah. Yes. Again, a connection loss. I reconnected it.
Yes, sir.
So, what I'm saying is, it's a manifest file. Any manifest file is an XML file. An XML file means it's not a Java code. It will have something like this. Say, suppose if you have a student XML file, it can have a start tag student and the corresponding end tag student. Meanwhile, you may have the value or you may have some subtags. Say student number, it could be something like this: start tag, end tag, and the value. Student number 101, student number 101, something. Start tag, end tag, start tag, end tag. Now student is a start tag, end tag is student. What the value of it is? This complete string, complete thing, the combination. So all is the partner value. That is again a XML tag. Student number, start tag, student number, end tag. Its value is 101, something like that. So it is an XML file where what we do is the starting point of the application will be specified somewhere. That is one of the thing. And secondly, I told you previously, we have one more session called components of the Android. Components, that's the next session. An Android application means is a combination of n number of the components. What the components we use, all those components should be registered here in manifest file. All those names has to be mentioned over here. Remember, Android application will have some components. In how many number of components you have, all those components has to be registered here in the manifest file, or else they couldn't be executed. When the execution comes, their execution comes in, they couldn't be executed. It simply ignores. So registration of all the components should exist. And thirdly, if I use any third-party libraries in my application, say it's a Google, it's a SDK, it's a Facebook, or it's a LinkedIn third party, or a Paytm wallet, or something like that. Any third party of libraries I use, those third party libraries has to be registered here. Those third party libraries has to be registered here. And then at the last, one more thing. Permissions has to be specified here. What all the kinds of the hardwares that your application utilizes, all those related permissions has to be specified here in the manifest file. If your application uses internet connection, internet permission has to be specified here. If your application want to access contacts, contacts permission has to be specified here. If your application utilizes SD card access, read and write permission, then that permission has to be specified here. So that at the time of installation, all the permissions provided in the manifest file will be listed to the end user. If end user say yes, it goes further, or else application wouldn't be installed. Got it?
Yes, sir.
So these are some of the important things that the manifest file consists of. What these components could be a new part to you. Once we cover that session, what components exist in Android, you will be clear with it. Huh?
Yes, sir.
So this is the folder structure of our Android application. This folder structure will have SRC, source code, and XML files will be in layout under resource, layout that existed under resource again, and images in drawable. All primary values, colors, styles will be existed as values, and Android SDK, an auto-generated file, we discuss that later, and a manifest file which will have these kind of the information. The launching behavior will be specified for some of the Java file, what it should be, and all the components that existed, they has to be registered, and third-party libraries that is being utilized in your application has to be registered. If any permissions we have, those permissions, if we use any permissions, then those permissions has to be specified here. Is something like this. Got it?
Yes, sir.
You had some idea now?
Yeah.
Yeah. It's already 8:17. We'll go home.
Okay.
Huh?
Okay.
See you guys again, and what we do is we can meet again at the same time. Huh?
Okay.
Yes, sir.
Sir.
Once I get the confirmation from these guys and all, so discussions are finalized, then we can meet at the same time. Let's wait for the invitation of the meeting. Hmm?
Okay, sir. Yes. Thank you.
Okay, guys. Thank you.
Thank you, sir. Have a good night, sir.
Yeah. Thank you. Thanks a lot. Bye.
Good night.
Bye-bye.